Okay, in this video we're going to look at performing arithmetic operations with functions, such as adding, subtracting, multiplying, and dividing. So we can add, subtract, multiply, and divide functions just like we can with real numbers. So just some notation things. First, for adding functions, we have f plus g of x means take f of x and add it to g of x. So combine like terms if necessary. The difference of two functions denoted f minus g of x is f of x minus g of x. The product of two functions denoted f times g of x is f of x times g of x. And then the quotient of two functions is f over g of x, which is f of x over g of x, with the condition that the denominator does not equal 0. So a lot of this is, combining like terms, multiplying out stuff, a lot of things you've done in prior math courses just with this new function notation. So for instance, if we have f of x equals x plus 2 and g of x equals x squared minus 4, then f plus g of x is going to be f of x, the x plus 2, plus g of x, the x squared minus 4. So combining those like terms, we get x squared plus x, and then 2 minus 4 is negative 2. So f plus g of x in this case is x squared plus x minus 2. So find each of the following now. For f of x is x squared minus 3 and g of x is 4x plus 5. So f plus g of x, once again, is going to be f of x, the x squared minus 3, plus g of x, the 4x plus 5. And combining like terms, we get x squared plus 4x, and then negative 3 plus 5 is 2. So x squared plus 4x plus 2. Part B, f minus g of x, and again, just wrote these up here in the header to not have to remember what they are, but it's going to be f of x minus g of x. Now, because we are subtracting g of x, and g of x has more than one term, we have to put that g of x function inside parentheses. So f of x is x squared minus 3, and then minus, in parentheses, the 4x plus 5 for g of x. So distributing that negative to both terms, we get x squared minus 3, and then minus 4x minus 5. So don't forget to distribute the negative. Combining your like terms, x squared minus 4x, and then negative 3 minus 5 is negative 8. So we get x squared minus 4x minus 8. Part C, g minus f of x. So that's g of x minus f of x. So we're going to switch the order here from the last example. So now the 4x plus 5, and then minus in parentheses for f of x, the x squared minus 3. So distributing this negative through, we get 4x plus 5, and then minus x squared plus 3. So now combining our like terms, we get negative x squared plus 4x plus 8, which if you go back and look at the answer to the last problem, is the opposite of f minus g. So f minus g was x squared minus 4x minus 8. G minus f is negative x squared plus 4x plus 8. So just like when we switch the order of subtracting two numbers, we change the sign of the output. Same thing with functions as well. So for instance, 7 minus 5 is 2, but if we switch it and do 5 minus 7, we get negative 2. So the exact same rule applies to functions. Part D, f times g of x. So we're going to take f of x, the x squared minus 3, and multiply it by g of x, the 4x plus 5. And I like to have mine multiplied out. We saw this in the complex numbers video, so it just helps me keep organized. X squared times 4x is 4x cubed. X squared times 5 is 5x squared. And now for the negative 3 times 4x is negative 12x. Negative 3 times 5 is negative 15. There aren't any like terms to combine inside the grid here. All the powers of x are different. So our final answer is just 4x cubed plus 5x squared minus 12x minus 15. All right, part E, we have f over g of x. So that's putting f of x, the x squared minus 3, over g of x, the 4x plus 5, and we're good to go. Part F, g over f, we're just going to flip it, take the reciprocal. So g of x over f of x is 4x plus 5 over x squared minus 3. All right, so that about does it for this video. Thank you for watching. I'll see you next time.